Today we're going to use the air track, and we're going to use this to collect data using a motion detector, which is set up right here. This motion detector will pick up the glider, and so this glider rides on the track. When we turn the air supply on, air is blowing out through these holes on top, and then this glider rides on a cushion of air, so we don't have to deal with friction. So we are going to first look at this glider moving along the track after I give it a push. So we're going to turn the air supply on. It's going to be a little loud because now we have a nice cushion of air on here. And then I'm going to push the glider, and we're going to collect the data, and it's going to produce a position time graph so we can see what this would look like. There we go. Okay, so that's our graph. Stop. So this would tell us, since this slope is very constant during that motion, that glider is moving with a constant velocity. Now, we're going to change it. I'm going to change up the glider, and I'm going to hook a string onto it and have a mass pull it over a pulley, and I will show you the setup. And then we're going to collect that data and look at how that graph looks different compared to this graph. Okay, so now we got the setup again. I have my glider. It's going to be riding on the track. We'll turn on the air supply in just a minute so it rides on that cushion of air. I have a string here that is over this pulley, and on the end of it is this mass. So that mass will fall freely and pull this glider along once I get it hooked up. So I'm going to hook it to the glider. I'm going to turn on the air supply so it's free to move. And then I'm going to start collecting and look at the position time graph for this. Stop. So here is the graph of the glider moving, being pulled by those masses over the pulley. If we notice this, the slope of this line is changing, because here is where the glider was sitting at rest, and then we can see the slope gradually gets steeper and steeper. The steepness of that slope is telling us something. It's telling us that the velocity is changing. When the velocity is changing, we say it is accelerating. So this is a good example to show how is a position time graph different from a constant velocity object compared to an object that is accelerating. So this is kind of our introduction to knowing how can we recognize an object accelerating by looking at a position time graph. We should have a slope that is changing, or the slope is not constant.